Model Context Protocol, or MCP, is the thing quietly holding together almost every AI agent you've used in the last year. If you've asked an AI tool to check your Google Drive, update a database, or book something online, there's a good chance MCP was working behind the scenes to make that happen. So let's break this down in plain terms, no coding background needed. An AI model by itself is pretty limited. Take any large language model, Claude, GPT, Gemini, it doesn't matter which one. On its own, it can only generate text, images, or audio. That's it. It can write you a beautiful plan for booking a flight, but it cannot actually go and book that flight. It has no hands. It can't click buttons. It can't send requests to a website. It can't touch a database. It just predicts words. An agent is basically a wrapper around that model that gives it the ability to act. It has memory, so it remembers what you told it earlier in the conversation. It keeps working, checking, and adjusting until the task is actually done, instead of answering once and stopping. And most importantly, it can use tools, which are just small pieces of code that let the agent talk to something outside itself, like a website, an app, or a database. Every single service out there, every airline, every app, every database has its own way of exposing data. One company calls it flight_search, another calls it search-flights. A third one wraps everything in a totally different format with different field names. If you were building an agent that needed to talk to 50 different services, you'd basically be writing 50 different adapters by hand. That's slow, that's expensive, and it doesn't scale. Anthropic looked at this mess back in November 2024 and released Model Context Protocol as an open standard to fix it. The idea is simple. Instead of every developer writing custom glue code for every single API, you build one MCP server for your service following one shared format. Any AI agent that speaks MCP can now understand and use that service instantly without anyone writing custom integration code for that specific pairing. Think of it like a menu. When an agent connects to an MCP server, that server hands over a list of what it can do. Search flights, book a flight, check a database, read a file, whatever it offers. It tells the agent exactly what input it needs and what output it'll give back. The agent doesn't need to guess the format, or scrape a web page, or reverse engineer an API. It just reads the menu and orders what it needs. The architecture is client and server, which honestly sounds more complicated than it is. The MCP client lives inside the AI tool you're using, say Claude Desktop, Claude Code, Cursor, or VS Code. The MCP server lives wherever the actual capability is, maybe on your machine if it's a local file system, or hosted on the cloud if it's connecting to something like a database or a business tool. When you type a request, the client asks the connected servers what's available, picks the right tool, sends the request, and brings the result back into your conversation. Now, this protocol didn't stay small. In its first 18 months, the official software development kits for MCP went from around 100,000 downloads a month to 97 million downloads a month. That's not a typo. 97 million in a single month just for the core SDKs. For comparison, it took React, one of the most popular tools in web development, about 3 years to hit that same download scale. MCP got there in under a year and a half. And it's not just Anthropic pushing this anymore. OpenAI added support across its Agents SDK and Responses API. Google confirmed support inside Gemini. Microsoft built it into Copilot Studio and Visual Studio Code. In December 2025, Anthropic actually handed control of the protocol over to a new group called the Agentic AI Foundation, hosted under the Linux Foundation, with OpenAI and a company called Block joining as co-founders, and backing from Amazon, Google, Microsoft, and others. That matters because it means MCP is no longer just one company's project. It's shared infrastructure now, closer to something like HTTP or USB, a standard everyone builds on top of instead of competing against. Estimates vary by registry, but multiple independent counts put the number of publicly listed MCP servers somewhere between 10,000 and 20,000 by the middle of 2026, covering everything from developer tools and databases to business apps like Slack and Notion to consumer stuff like maps and shopping. Back when MCP launched, connections were stateful, meaning the server had to remember an ongoing session for each client, which made it harder to scale across multiple servers at once. As of the mid-2026 specification update, MCP moved to a stateless core, so it can run on regular web infrastructure without needing to keep long-running sessions alive. There's also a new piece called MCP Apps, which lets a tool return an actual visual interface, like a form, a chart, or a small dashboard, instead of just plain text. So instead of an agent replying with a wall of text about flight options, it can literally show you a booking form right inside the chat. Security is the part people underestimate the most. Because an MCP server can read your files or touch your accounts, a poorly built one is a real risk. If a server pulls in content from the open web, like a web page or an email, and that content contains hidden instructions, an agent could get tricked into taking actions it shouldn't. This is called prompt injection, and it's the main reason enterprises have been cautious about giving agents too much unsupervised access. That's also why a lot of the recent protocol work has gone into authentication, so companies can control exactly which servers an employee's agent is allowed to touch, instead of approving every single connection one by one. Say you're using an agent inside your code editor and you ask it why a button disappeared from your app. Without MCP, it could only guess based on what it already knows. With an MCP server connected to your Git history, it can actually go look at the commit log, find the exact change that broke it, and tell you which line to revert. Or say you connect an agent to your company's payment system and your analytics database at the same time. You ask it why an invoice doesn't match a customer record, and it goes back and forth between both systems on its own, cross-checking data until it finds the mismatch and explains it to you in plain English. The fastest way to try this yourself is to open whatever agent tool you're using, whether that's Claude, Cursor, or something similar, and look for an MCP settings file. You add the name of the server, the command to run it, and any connection details it needs, like an API key or a database string. Once that's saved, the new tool shows up as available inside your chat, and you can just ask for what you need in plain language. There are already public directories where you can browse ready-made servers for things like Google Drive, Slack, or GitHub. So in most cases, you're not writing this from scratch, you're just plugging something existing into your setup. Regular AP is already existed long before MCP showed up, and the reason they weren't enough is they were never designed with an AI model in mind. A human developer reads documentation once, writes the integration code, and moves on. An AI agent doesn't work that way. It needs a description of what a tool does and how to call it, available right inside the conversation, in a format it can reason about on the fly. MCP basically packages that documentation into something the model can query and act on directly, instead of a static page that a human has to manually translate into code. Google built a related idea separately from MCP called agent-to-agent communication, where MCP connects one agent to outside tools and data. Agent-to-agent lets two separate agents talk to each other. Picture one agent that's really good at booking flights and a different one that's really good at booking hotels. Instead of cramming both jobs into one overloaded agent, you keep them specialized and let the flight agent hand off part of the task to the hotel agent, then wait for the result. The two protocols work together. MCP handles tool access. Agent-to-agent handles the handoff between agents. On the business side, Gartner has estimated that roughly 40% of enterprise software will include task-specific AI agents by the end of 2026, up from under 5% a year earlier. A chunk of that growth only works because of standards like MCP, since it's what lets a company plug an agent into its CRM or support ticket system without rebuilding everything from scratch. Slack, Notion, Atlassian, and Figma already ship an official MCP server, which tells you they're betting a real slice of their future usage comes through an agent instead of a person clicking around the app. None of this means MCP is finished. The protocol is still changing fast, security practices are still catching up to how much access these agents get, and a lot of the public servers floating around registries are unofficial, meaning nobody's guaranteeing they're safe. If you're experimenting, stick to official or well-known servers first, and be careful about what permissions you hand over, especially anything touching payments or private data. That's the core of what MCP actually is. It's not magic, it's a shared language that lets an AI model stop guessing how to talk to 100 different services and instead just ask for what it needs in one consistent format. And given how fast every major AI company jumped on board, it's probably going to be the thing your tools are quietly running on for a long time.